All right, so again, we've been talking about the octet rule and the valence electrons and the valence shell because this is what it's all about. That's what determines bonding, right? Whether things are going to, whether atoms are going to bond or connect with each other or not, is their outer shells, right? They want to try to reach that octet rule. If they have one shell, it's a maximum of two. If they have more than one shell, it's a maximum of eight on all those shells, right? So we saw the video at the beginning, just kind of introducing the difference between ionic bond and covalent bonds. So again, ionic bonds occur when one atom donates one or more electrons and the other atom accepts those electrons, right? So remember, an ion is an atom that is either positively or negatively charged, right? That is the definition of an ion. So when you have a positive and a negative ion, I don't know if you've ever heard the term opposites attract, but that's what happens here. And remember, if an atom gives away its electrons, it's overall going to become positive, right? Because it's getting rid of negative things. And if another atom accepts those electrons, it's going to become overall negative because it's taking in negative things, negative charges, so it becomes overall negative, right? So one becomes positive, one becomes negative, and opposites attract, and so that is ionic. Covalent occurs when atoms share electrons. I always think of covalent and cooperate, so I don't know, it kind of like what helped me remember that. But there are two types of covalent bonds, right? Nonpolar covalent means that it is shared equally, the electrons are shared equally, and polar covalent means that they are shared unequally. So I know it's kind of confusing, but if you remember the word polar, like if someone is your polar opposite, that means that they're not the same as you, right? They're different. Or you have a north pole and a south pole, it means that they're at opposite ends of the globe, right? They're opposite, they're different. And so if atoms are different one from the other, then one of them is going to pull the electrons more than the other. Remember that word electronegative? Remember that means electron hog, right? So if one atom is more electronegative, it's an electron hog and it's hogging more the atoms more than the other atoms. So it's kind of pulling them more. And if something is nonpolar, which is a little bit weird to understand, but nonpolar means the same, right? Nonpolar means like non-different, which means the same. So if two atoms are the same, then they share them equally. And you'll see what I mean in a second. Right, so here we're going to starting with the ionic bonds. So an ionic bond, remember, is when one atom gives away an electron and the other one accepts that electron. So right here, these is kind of like an example right here. That yellow dog is giving away its electron, which in this case is the bone, right? So think of the yellow dog as Na sodium and that gray bulldog as chlorine, right? Cl. So basically, that yellow dog gives away its electron, and in doing so, it becomes slightly positive because it gave away a negative electron. That gray dog accepted that electron, and again, the electron's negative, so that made that gray dog overall negative. And so a positive and a negative are opposite, opposites attract, and so this is what is causing it to bond right here. Right, another example right here. Again, these are just like the outer electrons that you're seeing right here. Na has one electron on its outer shell, that yellow one, and it's giving it to the green Cl atom. Right, when it does that, the Na becomes positive because it gives away a negative electron, and so it becomes positive. That Cl accepted a negative electron, and so that Cl becomes minus. Right, it becomes negative. And so because one is positive, one is negative, they're opposite charges, opposites attract. And remember, NaCl right here, this is table salt, right? It's a compound that we learned about earlier. And it is table salt, and it is an ionic bond, right? Because one becomes a positive ion, the other becomes a negative ion, and ions attract, opposite ions attract. And so here, positive and a negative, they attract. Right, and this is another example. It's the same thing you saw right here, NaCl. It's just in an image instead of a GIF, right? And so here again, this pink electron on the outer shell, it's by itself. And again, it's easier to give away one thing than to find seven. So it gives away that electron there. And in doing so, you see over here, it gives it away. The chlorine accepts it. And when it gives away that negative electron, it becomes positive. This one accepts that negative electron and it becomes negative. And so now a positive and a negative charge, opposites attract, and then you have that ionic bond right there.